Sam, good to meet you. I know we haven't met in person yet. I met your team in Austin at our event recently, but yeah, thanks for joining us today or joining me.
Well, I'm very glad to be here, Pete, and maybe we will soon meet at one of the upcoming Edge AI Foundation events because
Yes, that would be
that's where
good.
the community is.
You look like you're in a very soundproof kind of chamber. Where are you calling in from?
I'm calling it from our one of our little phone booths at our headquarters. We are in San Bruno, California, so it's
Right.
maybe one of the lesser known cities, but it's where
Yeah,
SFO
San
is. So
Bruno. It's near
yeah,
the
exactly.
airport, is it?
5 minutes
Or
from the airport. It's where our office is.
yeah, exactly. So I think everyone has a subconscious idea of where San Bruno is because they've seen the signs near the airport of where San Bruno is.
Yeah, exactly. So
So you guys are just kind of getting into it a little bit for our listeners, FemtoSense, who may have not have heard of you yet. You're a Bay Area based company. You were spun out of Stanford. Is that the or what, maybe give us the origin story behind
yeah,
FemtoSense. What's up?
Yeah. So we are a Stanford product, could say.
Hmm.
Myself, my two co-founders, Alex and Scott. We are all doing PhD work in the same lab, the Brains and Silicon Lab at Stanford, as part of the neuromorphic engineering community.
Hmm.
So doing AI, perhaps before it was cool, or as cool as it was as is now. Um, and we'll come to the conclusion of the PhD program around 2018,
Yeah.
and we look around and it's like, oh, this AI stuff is kind of picking up out there, right? And
Yeah.
that's one. And then two, it looks like silicon in particular is starting to become sort of an investable class of business. Companies
Right.
that are involved in silicon, whereas
Right.
previously that might have, during like the heyday of SaaS, that might not have been true. So it's
Mm.
kind of this combo of opportunity. See this technology that we were developing. The market seems like it's interested in this, and it seems financeable. So you know
Right.
why not? That's sort of the pipeline, and the whole mission of the place is to get useful technologies, products out to the world, and it was a
Mm.
good time for us. So that's what we did. We basically took um, at least initially, actually, the research chips that we had made, looked to build a company around it. That's kind of where
Right.
the origin of the company name came from. Femto is the SI prefix for 10 to the minus 15. So it's very small. And
Yep.
the Jeopardy question is sort of how much energy does it take for one neuron in your brain to talk to another neuron, right? And
Mm.
that little communication between there is on the order of femtojoules. So
Oh.
if you can make electronics that, you know, at their base level work on those that order of magnitude energy for sort of communication, oh, it's just a matter of sort of architecting and engineering and programming it to get it to holy grail of artificial general intelligence.
Right.
But yeah, that's kind of where it came from, right? And
So you're trying to create edge AI platforms that are as efficient as the human brain.
yeah, there's a few. Speak of SI prefix, there are a few orders of magnitude to go before what we currently have out in the world is sort of anywhere near what you
Yeah.
or I are sort of running off. Like we just had lunch.
Right.
We can go for probably a day plus, yeah, with fairly coherent thoughts. So yeah, there's definitely some plenty of headroom in terms of what you currently see in the world and what the world could be. So that's
Yes.
kind of the angle here.
I had heard we had AI Zip on, and they were talking about kind of efficiencies of I mean, sort of. I know you've probably seen this too. Like the human brain is kind of running at about 20 watts or so, or something like
Yep.
that. Relative to a giant data center that's in the kilowatts or megawatts.
Yep.
And so, yeah, it's definitely several of those orders of magnitude we have to go on that
Right,
space.
exactly. When
Yeah,
when sort of nuclear power starts to come into the conversation in terms
yeah,
of serving all the stuff. I mean, okay, that's maybe one way to handle it. The
yep,
other way to try to handle it is be a little bit more, um, put a little more thought into how
yeah,
things are being done. Because if you can get the efficiency, yeah, there's plenty of savings there. And this is something that I think also popped into the news in the last month or so. With the like the deep seek models, right? It's
hmm,
like, oh wow, you really proved that while you can throw jewels and cash at the problem, you can also go, you know, build these capabilities in other ways. And there's a lot of merits to that because it becomes more scalable, more economical, and all of this has to sort of make sense
Right.
for this AI um, field to really be successful. You can't
Right.
just
Right.
be wasteful about everything.
Right. Well, I mean, they say efficiency is the new currency, so DeepSeek sort of proved that. And like you said, I think this is kind of where our community is really, on the frontier of how to create hyper efficient AI and, use power and cost and for maximum impact. And
Yeah,
so that's,
absolutely, absolutely.
yeah,
Yep.
that's
You talk to the folks, integrating these systems, while they often have a very powerful AI, on the back end,
Mhm.
it does cost something to run that. And while that's coming down, there there are still discussions about how to make that sustainable. Do you like if this is a physical product you are buying,
Mm.
is there now a subscription with it? And yeah, I don't know if I want to pay a subscription for every single physical device I have.
Right.
However, there's a subscription that we are all paying, which is just our electricity bill, and we are very comfortable paying that. In this case, it's to Pacific Gas and Electric. But yeah, if you can deliver those AI capabilities right then and there, yeah, you don't have to worry about that sort of new business model. And of course, because it can run on your device, it must be very efficient. So that overall is just a nicer impact on the
Right.
planet. So
Yeah.
yeah,
And
there's a lot
it's,
of merits to it.
there's a gravitational pull toward the edge, for computing. And it's like, running computing where the data is created is usually the most efficient, effective, and secure way to get things done.
Yeah,
Um,
yeah, yeah.
but
Didn't
you
even
guys
get
are
into all the private stuff. Yeah.
yeah. So would you characterize the work that you're doing kind of in the neuromorphic realm? Are you in the neuromorphic world? Uh,
Yeah, it
in
kind of depends
terms
on who you ask. I mean, we definitely came from there. That was the
mm,
PhD work. We'd have some, let's say, technology, you could say, pivots along the way.
mm,
The way that I cast it is that, what's good for research might not always be the best for commercialization. So yeah, in the PhD world, it was the full, um, vision of how that might, how neuromorphic might come to pass.
right.
Subspatial analog, uh, circuits behaving very closely to what an actual neuron would do, at least
Right.
mathematically. You had no clock on the chip, full asynchronous communication and compute for anything that was digital, and you had spiky neural network sort of programming frameworks and
Mhm,
uh, yeah, algorithms. And yeah, we were like, okay, for the first year of the company, it was just trying to commercialize that.
mm,
We found that there were some challenges associated with that. So the main two are programming. So that style of compute is a little bit hard to get to perform competitively with standard deep learning based backpropagation. And then the other big challenge that we recognized with that approach was about manufacturability, variability, sort of reliability. When you're dealing with systems where it's a real physical thing, which means
mhm,
physical things like process variation, how much dopant is in each part of the transistor, temperature, and if that can change your behaviors and make it non-repeatable. When you get to real economies of scale or commercial scale, that could cause some real problems in terms
mm,
of the commercialization. It's nice to have an abstraction, the digital
mhm,
abstraction, to sort of absorb all that variability so that you can deliver something that's reliable. But more than that, we're thinking that, well, why are these systems very efficient, right? And does it have to be implemented in that same way?
mm,
And we came to the conclusion that, well, these systems are efficient largely for two reasons. One is the sparse compute, these spiking neural networks, all of these neuromorphic systems. They don't do heavy operations unless they really need to. And those
right.
heavy operations are mostly communication, like point A to point B.
Mm,
Yeah, if you don't have an input, then you probably shouldn't do anything. So yeah, that's sort of the basis there. But the question is, does it need to be in this sort of unary, binary, mode of compute with these spikes? And well, you could get sparsity similarly from a rectified linear unit. So why don't you do that? And then similarly, the other idea, which is, or the other principle, I think you could say it, that makes these neuromorphic systems very efficient is just that they don't move things very far. So there's sort of the time and space component of this. The time we just talked about, sparsity, the space
Right.
is, well, when something happens, everything is sort of local to that event. So whether you're doing, this is like compute and memory stuff, um, as you're not moving things between far flung memory banks and logic blocks, yeah, you're saving, probably the largest cost in terms of where the energy goes for these modern processes.
Mm.
But the question again was like, well, does that really need to be in totally analog sort of fabric? And it's like, well, no, this is not a black or white thing. It's definitely shades of gray. You could use a standard segregation between memory and logic, but just chop up the structures so they're much smaller and closer together. Right.
Mm.
So as opposed to one giant block of memory over here, one giant block of compute over here, chop it all up and mix it together, make your compiler smarter to handle that. And now you've
Hmm.
shrunk that distance and you've gotten like 90, 95% of what you could
Mm.
do otherwise. So
Right.
all that is to say,
Interesting.
like, well, yeah, the ideas are good. The reasons why it's efficient, they're true. These are just physical devices, same as everything. But you can make them in much more manufacturable, reliable, and programmable um, instantiations. And so, why don't you go do that? So
Right.
that's
Right.
kind of our journey from the sort of pure research that we were doing to the
Hmm.
more how can we take ideas from there and inspiration from there and actually make something that is easy to use, reliable, can be mass produced, can get to market quickly, all the
Right.
things that kind of a company also has to satisfy beyond
Mm.
just a single measurement or a single benchmark that you might be incentivized to do if you're just trying to have something to show.
Right. Yeah, no, I think that makes sense. I mean, getting it at the end of the day, it has to be commercialized to generate revenue, right? So I think that's pretty key. Where do you
Yeah.
see like kind of your key industries? What are your hot industries that you're going after, or scenarios, or canonical use cases where you think that your stuff would really shine?
Yeah, everywhere really. It's like everybody has. I think on average, there's like 18 to 20 devices or something on all of us or in our home,
That's
right?
true.
So
Yeah.
all that
Yeah.
stuff could have AI in it. More concretely, you have to start somewhere. So where we're starting is in sort of the consumer hearable space as well as smart home space. So in the consumer hearable space, for example, beyond the right after the Edge AI Foundation meeting in Texas
Mm.
last week, we had like a hearing aid conference. So we
Mm.
were showcasing, um, and we and our customers, we call New Sound, we're showcasing their first AI hearing aid, right? So that has
Mm.
our tiny little bit of silicon in there, uses all the principles I just talked about. It's a very demanding kind of product category. These things have to last the whole day, right?
Yeah.
10-hour battery life isn't going to cut it, although that would be impressive for something like an AirPod. Um, for a hearing aid, you got to go like 24 hours, right? So if you deliver, noise cancellation, speech separation, all those sorts of features on a 24-hour battery life in that form factor, yeah, that could make a difference. So that's one segment that we're in as an initial beachhead market. The other one is in home appliance space. Um, you know, the previous iteration of this kind of product category was Internet of Things, where you kind of control things with, your phones and devices. I may
Right.
not want to do it. I may just want to talk to it directly, right? With or
Right.
without connectivity. Right? So having the smarts on my device, like an air conditioner, I sit down. I may want it to be cool initially, but then once I've been sitting for a while, I may want to have that off, and I could just say, "Hey, air conditioner, turn off." Those kinds of convenience features is the other segment that we're initially in. But I'll go back
Right.
to those principles we're talking about, sparsity and locality. Those are not, of course, tied to any modality or any market.
Right.
How you navigate the markets is really just a question of, you know, where you want to deploy your capital initially,
Yeah.
where you think there's opportunity, and take the economics and grow from there. Build that flywheel so you can
Yeah.
make it sustainable and good impact.
Although I guess the hearables, wearables market, where you've got that, obviously the battery life is such a huge value proposition there.
Yes.
So power efficiency there probably has even more of a superpower than like I would say like a Ring doorbell or other things like that,
Mhm.
where it's power is important. But with hearables or wearables, I mean, just like even with my Apple Watch and stuff, like the only reason I bought the Ultra is because the battery was bigger, so I could like last like
Yeah,
2 or 3 days on it as opposed to charge it every night. So
really.
um, I can
Yeah, it's
imagine that.
interesting being in disparate sort of markets where they care about maybe some things, but maybe some things different.
Hmm.
Totally agree with you that the wearables, hearable space,
Yeah,
battery and cost are sort of the prime drivers,
yeah,
and the other like smart home space, like if you're an air conditioner, you that thing consumes so much power in its normal
Yeah,
function that
that's right.
any of the power that we talk about doesn't really matter. However, what does matter to them is cost, right? And so
True.
these ideas of sparsity, where we talked about the time component, there is a space component as well. If you say that you only need to store, like, deploy silicon for 10% of this model, well, you've just shrunk your silicon footprint and hence your potential cost by 10, right?
Yeah.
So that's perhaps a little bit more important for them than the power. I mean, the power is important. There are
Sure.
energy
Yeah.
efficiency standards that people have to satisfy, but yeah,
Right.
relative to the overall device operation, it tends
Yeah.
to be more that the cost is the important thing than the
Yeah. And that's a huge thing. I
efficiency.
mean, you can't underestimate. I've seen so many projects they get to the POC stage and they just don't get to commercialization because the ROI is
Yes.
not there. And the
Yes.
costs, it adds up. And especially, I mean, you're talking about consumer products, which have a notoriously low margin. Um, and but across the commercial space, there's quick serve restaurants, I mean, all kinds of vertical markets too, where the cost of these solutions, like every penny counts. And so I
Yeah.
think bringing the AI into something that fits inside an ROI envelope is like kind of
Yeah,
required.
exactly. Yeah, there's some pretty good, development platforms out there for edge AI that are, sort of like mini GPUs.
Right.
um, and those are great to get to that point, which is the POC, which is say, hey, can we
Sure.
enable this feature? Then you have to take it to production, and that's when things become a lot harder.
Yeah, that's right. Everything gets squeezed. Um,
Yeah.
yeah, cool. So are you focusing mostly on the US market now, or are you worldwide, or what's your
Yeah, worldwide. So while we're based here in the US, we have a lot of
Mhm.
activity in Asia. That's where a lot of electronics just happens.
Yep,
um,
a lot of
at least
stuff,
for
yeah.
now. We'll see. We'll see with all the
Yeah.
trade stuff going on.
I know, yeah.
Um,
Yesterday's
right.
news.
Yeah. And then there's we have a good amount of projects going on in Europe as well.
Cool,
So
cool.
yeah, it's definitely
Excellent.
a global world, and every geography is looking to add these
Mm,
smart features either to their products or to kind of be on the forefront
right.
of, I guess, this super cycle, as
Yeah.
maybe some people call
Well,
it.
and I guess also as a kind of a startup, in this space, you kinda need to go where the business is. So, if
Yes.
there's interest somewhere, you need to be there and make it happen, right? So,
Absolutely.
and then getting that voice of the customer into the product cycle is so critical so that you can, build stuff that's, you know, fitting some real needs out there, which is pretty critical. So,
Yeah,
yeah,
exactly,
cool.
exactly. The product developers, well, you know, the wider audience may know the biggest companies in the world, like the Nvidias, the Qualcomms, Intels, right?
Right.
The people who actually build the products, especially in this more consumer electronics space,
Right.
they have a whole complicated supply chain. And so
Very
it's very
yes, very
important to be out there, engaging, known, so that the product developers have the best possible solutions to, of course, bring to
mhm.
their customers and ultimately ourselves as consumers.
Right, right. Yeah, and I would say also I'll have to tip the hat, the Edge AI Foundation hat to FemtoSense because you guys joined recently, and I know that you have a representative on our marketing working group. You also have a
Yep.
representative on our program committee for Milan.
Yep. That's
So
very
for folks
exciting.
who have not yet registered for the Milan event, you can go there. So yeah, I really appreciate you guys have really leaned in to help out the community and get help with your business as well. So that's really appreciated.
Yes. Yeah. No, it's been great. We only joined recently, but I think we've gotten a lot out of being a member, the JI Foundation. For all of the suppliers, vendors, customers here, we
Hmm.
all have largely the same problems, right?
Yeah.
When it comes to just being known in the broader marketplace, being understood by total layperson. Like, how would you explain all this to
Right.
grandpa, grandma, grandpa?
Right.
Right? These things don't have to be solved independently by every single person. We can sort of
Yeah.
put some heads together to think about it too.
Yeah. No, definitely the collaborative vibe. So yeah, cool. Well, Sam, I appreciate the time. And look forward to more collaboration with FemtoSense. And certainly maybe I'll see you in Milan or if not sooner. But yeah, best of luck. It sounds like you guys are on a really good path.
Great. All right. Well, thank you, Pete. And yeah, I look forward to meeting you and other Edge AI Foundation people in the near future.
Sounds good. All right. Thanks,
Great.
Sam.
Yeah, take it easy.